Okay, let's go ahead and get started. Hello, everyone. I'm Charlie Smith, the Principal Consultant with ESIG. I also serve in a leadership role with the Global Power System Transformation Consortium, or G-PST, whose mission is to bring together key actors across the globe to catalyze a rapid, clean energy transition at unprecedented scale and speed. This is being done by providing a coordinated and holistic approach to the necessary knowledge, education, and support to power system operators across the 5 action pillars. At the core of the G-PST is a large cross-section of system operators from around the world who are dealing with a rapid transition from a system based on synchronous machines to one built around inverter-based resources. The 5 pillars of the consortium include research and peer learning, technical support, workforce development, standardization, and open data and tools. ESIG is the co-lead on Pillar 1, along with Mark O'Malley of Imperial College, and more information on the G-PST can be found at globalpst.org. As a co-lead on Pillar 1, ESIG would like to welcome you to the April monthly webinar of our joint G-PST Pillar 1 ESIG webinar series. This series is in addition to the regular ESIG monthly webinar series and focuses on the G-PST research agenda and associated topics being addressed in Pillar 1. Topics are presented by both system operators as well as members of industry and the research community. An additional series of webinars on the other 4 pillars of the G-PST is also being provided on a monthly basis through NREL. For those of you who would like to learn more about the G-PST and how to engage, please go to globalpst.org and click on the Get Involved tab. Further information on ESIG can be found at esig.energy. Next, I would like to go over a few logistical matters before we get started. First of all, lines will be muted for the duration of the webinar to avoid unnecessary distractions. For the Q&A, we will use the Slido platform at slido.com. To ask a question, please navigate to slido.com and enter ESIG30 as the event code. The instructions are also at the bottom of the screen. You will see a thumbs up button next to the questions on Slido to allow you to cast a vote to help prioritize the questions submitted. We plan to save about 10 minutes for Q&A at the end and then wrap it up at the top of the hour. An email with a link will be provided once the video file has been posted. We also plan to provide short responses to unanswered questions after the webinar, so please don't be afraid to ask your questions through Slido. Today's topic is on Ireland and Northern Ireland's operational policy roadmap for 2025 to 2035. As you might imagine, with the changing nature of the resource mix due to the retirement of conventional generation and its replacement with variable renewable energy resources, many aspects of system design and operation are changing. System operation is vitally important as it represents the critical function of keeping the load and generation in balance on a minute-by-minute basis to maintain a stable system and reliable operation. We saw a good example this week of what happens when things get out of balance. This is a topic that has been around for quite a while, in fact, as long as the industry itself, and continues to be one of high interest and critical importance. EirGrid and SONI are currently operating the power system on the island of Ireland, with up to 75% of demand being met by wind and other non-synchronous generation sources. They have ambitious plans to increase this limit further and to achieve some of the most ambitious renewable targets in the world. Today's webinar will provide an up-to-date view of their plans in this field and will be presented by 2 members of the respective TSO staffs. They are Simon Tweed, manager of the Future Operations Policy Team at EirGrid, the TSO of Ireland, and Dave McGowan, the head of Future Power Systems at SONI, the system operator of Northern Ireland. Over the years, I've come to greatly value and appreciate the work going on at EirGrid and SONI, their participation across so many industry activities, and the leadership they are providing. I look forward to hearing what they have to say. Okay, just a short reminder once again to use Slido at slido.com with the event code of ESIG30 to ask your questions. So let's go ahead and get started. Dave, I will now turn it over to you.
Charlie, thank you so much for your warm welcome, and everyone on the call. We just really appreciate you taking the time to listen to, I suppose, the operational policy changes that we're doing across the island of Ireland. So myself and Simon are going to cut this in. I'm going to give you a slight introduction into Ireland, the island of Ireland, and I suppose the changes that we are driving through in policy and the power system over the next decade. So if I just cut to the next slide, SONI, as Charlie has mentioned, we're the transmission system operators for the island of Ireland, and there's two transmission system operators. EirGrid, I'm responsible as the TSO in Ireland, and SONI, the TSO for Northern Ireland. We operate the transmission system, so we manage the power flows across the network. We dispatch and schedule on a centralized dispatch model within the energy market, and we also deliver the system services through central dispatch on the island of Ireland through our system service products. In terms of what we do, SONI and EirGrid work jointly. We're a collaborative sort of group model where we have SONI and EirGrid, two companies within our group. And together we are working on our operational policy roadmap on how we change, how we deliver those inverter-based resources. As Charlie has mentioned, that's the drive towards we need to get to net zero. And in terms of what we do as the system operators, we have really recognized the fact that we need a strong plan and a series of clear objectives to allow us to deliver on our future net zero capability. So in terms of what we've done, we first published our operational policy roadmap back in 2022, and we committed to industry that we would review that on a regular basis. And this is our release of the next iteration. So previously, we gave a plan out to 2030, and now we've taken that plan out to 2035. In terms of what we're trying to do, we're trying to evolve three key policy areas. And in that, we are really seeking to realize our decarbonisation goals that are set down in our policies in both jurisdictions. We need to look at our dynamic stability of the system, and really Simon is going to take us on a little deep dive there this evening in terms of the overall programme, and it'll give you a real feel of how we've constructed the operational policy roadmap, the context of the need, and then in terms of our plans to deliver and make those changes. Simon's also going to then take us through, I suppose, some of the key areas of challenge in our system at the moment and how we are tackling that internally within both organizations to drive the relevant changes that will allow us to maintain that fine balance between supply and demand. Then we're looking at our reserves and our ramping products. And I suppose one thing that has came to me sort of over the last number of years working in the power system is really, you know, when we look at the island of Ireland, we're an island off a continent. But shortly we are being sort of integrated into continental Europe through the Celtic interconnector, and that means big changes. And Simon will maybe briefly sort of introduce some of those aspects as we look at the integration of ramping into our system as well. And then in terms of operational security is sort of the third pillar of the overall operational policy roadmap. So Simon, maybe you move to the next slide, please. So just to give you an overview of this evening, I'm going to give you a brief introduction to sort of where our current status is in the all-island power system, where we have come from and where we are aiming. Then we will take a look at the operational policy roadmap over the next decade, and that will be led through by Simon. And then we'll give you a little bit of insight in terms of how we actually do policy change within both organizations in terms of making those changes realizable within the all-island operational policies, procedures and systems. And then again, how we also interact with our stakeholder fora and make sure that they're up to speed and they are brought along the journey with us and enable the technologies and the policies and the various aspects of how they interact with the ecosystem. So we'll introduce that at the tail end of the presentation. So the next slide. Yeah, this is just a picture of the island of Ireland, and on that we have, I suppose, superimposed the transmission system. So we do have two jurisdictions. They both have, I suppose, different regulatory authorities. We obviously have two policy environments set by the Irish government, and then the local devolved assembly in Northern Ireland are actually responsible for energy policy. So they set our energy policy in Northern Ireland. So I suppose from the two jurisdictional aspects, that's what we really mean. We have obligations then as two TSOs to fulfill our legal obligations and mandates to operate and plan the transmission systems in Northern Ireland and Ireland. However, we are one synchronous area and we are one single electricity market, and that's recognised both at an EU level and at a sort of a jurisdictional level. And that's really important in terms of how we sort of manage and plan our system, and both TSOs plan and maintain and operate on the all-island basis. At a transmission level, we have 4 voltage levels. We have 110, 220, 275 and 400 kV. We have jurisdictional transmission control. So again, we do have two asset owners in the island, and in terms of the jurisdictional transmission control, it does mean that SONI are responsible for the transmission control in Northern Ireland, and EirGrid on the other side are responsible, working in conjunction with the ESB networks in Ireland to manage the transmission system in Ireland. We do have all island scheduling and dispatch. So that means in terms of Ireland, in the Dublin control room, there will be often times where they're scheduling on an all island basis, and then responsibilities may flip across to the Belfast control room. So again, the scheduling is on that all island basis, and the two control rooms work complementary to one another. From a demand point of view, we had a record peak winter past. So we increased our peak demand from around 7 gigawatts to 7.5 gigawatts last year. Our min demand across the island is 2.7 gigawatts. And I suppose the key driver for demand over the past number of years has been global tech arriving on the island of Ireland, and the growth in pharma across in Ireland as well, in terms of foreign direct investment. In terms of the generation portfolio to date, December 2023, across the island, we had 6.3 gigawatts. We had a peak wind of 4.63 gigawatts in December 2023. We have solar rapidly growing across the island, and I think indeed Ireland is now at, I think, 1.4 gigawatt, Simon, and maybe 2 or 3 years ago it was pretty much zero in Ireland in terms of the level of solar PV. So there has been an absolute rapid, phenomenal growth in solar across the sunny island of Ireland. There is a small amount of hydro, Runner River, and some pumped hydro on the system as well. In terms of our primary fuel imports, gas, oil, coal are typically imported onto the island. Our largest single in-feed and our largest single out-feed is due to our interconnection, and you can see on the right-hand side there, we have 3 interconnectors that are live. We have plus or minus 500 megawatt on our Moyle interconnector connected between Scotland and Northern Ireland. We have then EWIC sort of connected there from Ireland into Great Britain, and also the newly commissioned Greenlink interconnector. And across our interconnectors, we have 2 technology types. So we do have the voltage source control, HVDCs in Ireland, and we have the line computated control in the north. And that does give us very different sort of problems and issues that we'll have to resolve across the island in terms of how we manage our interconnectors. Okay, next slide. So just where we've been, 2010, again, earlier I said, look, we had low renewable volumes. I suppose back in the day when the Irish power system first kicked off, it was built upon the hydro power plants. But back in 2010, there was a heavy reliance across the island on coal and gas. and oil-fired generation, and the renewables may have been at a lower level, sort of around 10%. In 2020, we had targets set for 40% renewables by 2030 or 2020. As we approached recently, our targets for 2030 have been set to 80% renewables in both jurisdictions. And then in terms of our long-term mandate across both jurisdictions, we also have net zero obligations in our energy systems in Northern Ireland and Ireland. So there's a real clear decarbonisation policy framework that is backed up by that legislative sort of climate commitments in both jurisdictions. Most of our renewables comes from onshore wind, and the variable nature of that obviously has to be accounted for. And as I say, there has been the rapid uptake of solar PV, both at a grid level and also behind the meter level, and they both pose very different challenges due to their variability and non-synchronous nature. And again, as I mentioned earlier, demand growth within the Ireland power sector has been very rapid in terms of the investment in global technologies and pharma companies, and that has been sort of across the last 5 years, and that has really seen us come even to bring up about those large increases in peak demand and the new records that we're seeing on a regular basis. So I'll pass on to the next slide then, Simon. In terms of the fuel mix, really in terms of the energy mix for 2024, 40% renewables is where we're at. Currently, there's a number of renewable support scheme auctions that have taken place in Ireland, and that has set forward the rollout of renewables over the next number of years to hit those policy objectives of 80% renewables by 2030. So we're expecting to see a rise in the renewable penetration over the next number of years. You can also see here that, you know, we do have a dependency on their imports of about 12%, and then our gas-fired generation is then the balancing mix in our energy supply over on an annual basis. So really in terms of where we're heading, again, the policy framework setting us to get this renewable penetration up to around 80% renewables. And I suppose Simon is then going to take us through the operational policy changes that will be required to allow us to move this system with much greater levels of inverter-based resources within our ecosystem. So I'll just pass on to the next slide then, Simon. Just worthwhile sort of setting the key metrics that we have in our power system today to help us manage our dynamic stability. Probably the key ones that we have is the rate of change of frequency. In terms of where we sit on the island of Ireland, we do have a plus and minus 1 hertz per second rate of change of frequency. That was increased as part of our endeavour to get to 40% renewables by 2020, and has been in policy, and indeed we do constrain our system and manage our system to that level of rate of change of frequency at the moment. We have a minimum inertia floor across the island of 23,000 megawatt seconds, MVA seconds, apologies. And in terms of, we also then manage our system by ensuring that there is a minimum number of large synchronous units connected to the system to ensure that we have our dynamic stability and security within the system. And as Charlie mentioned earlier, we do have a system non-synchronous penetration limit of 75%. And in terms of the operational policy roadmap, Simon's going to give us a flavour tonight of what we endeavour to do to allow us to lift that level and integrate even more renewables onto our system. And in terms of the metrics, these are today's metrics, and we really are needing to shift our metrics into more sort of needs-based metrics, and that has been identified and set out in our operational policy roadmap. But I'll allow Simon to provide the information in terms of what metrics are maybe flowing away and which ones are going to be sort of our guiding policy metrics into the future, so that we can indeed integrate many more inverter-based technologies into our system. Okay, I think I'm passing over to Simon at this point. So thank you everyone for listening so far, and do, as Charlie says, make sure your questions are coming in on the Slido. So thank you.
Thanks, Dave. Can you hear me okay? Just making sure the sound is coming through. You can hear me? Yep.
Yep, Simon.
Yeah. Okay. Yeah. So the second part of the presentation is getting into our updated operational policy roadmap itself. As Dave mentioned, this is the second iteration of our roadmap. So extending now out from 2025 out to 2035. It is a published document. It's up on our respective EirGrid and SONI websites, so it should be relatively easy for people to find. And I have a link to it at the end as well. But I'm going to give a flavour for, I suppose, the contents of the document, an overview of the contents, and we'll focus in on particularly some of the dynamic stability policies and how we anticipate that they will evolve, and as well focus on some of the key enablers that are needed to be able to deliver on this roadmap. So the table here, I suppose, is a list of all the policy areas which the roadmap touches, and we've divided it into three kind of categories of policy, which are dynamic stability, reserves and ramping, and operational security. Within the dynamic stability is some of the metrics that Dave has just mentioned there, like rate of change of frequency. We also have inertia in there, the minimum number of units on the system. So the system-wide policies that we need to keep the system dynamically stable. And for each of those metrics, this table provides a definition of each of those and what the current operational policy or operational limit is as applied at this point in time. So I'll in the next couple of slides, I'll focus more on some of those dynamic stability and how those policies will change, but maybe just to touch on the others first, just to give a flavour for it. So on reserves and ramping, we have our categories of reserve services that we operate with on the system. So they're frequency response services from very fast frequency response through primary, secondary, tertiary, and replacement reserves that we need in our system. As Dave highlighted, we are an island system. We have a relative to the size of our system, I suppose we have a relatively large single loss event, or largest single in-feed or largest single out-feed, which today is up to about 500 megawatts, which can be sort of at times sort of 10 to 15% of the generation capacity or demand on the island. So the reserves needed to be able to, I suppose, manage a loss of that in-feed or out-feed are very important to us. And the roadmap sets out how those policies will evolve, especially as we're getting as a new HVDC interconnector will connect in a couple of years' time to France, and that's going to increase our largest in-feed and out-feed from 500 megawatts up to 700 megawatts. So that's going to increase our reserve requirements substantially. And then the operational security area is more about, I'd say, steady state management of voltages and thermal flows on circuits on the system, and also covers short circuit management to keep essentially voltages, flows, and short circuit levels within ratings of equipment on the system. So as I said, we'll focus a bit on the dynamic stability in the next couple of slides here. So this slide summarizes some of the key policy aspects related to dynamic stability over the 10-year horizon of our roadmap. An important kind of dynamic stability metric that we use is the minimum inertia floor of the power system. So today we as Dave mentioned, we have a minimum inertia floor of 23,000 MVA seconds for the island as a whole. We plan to evolve that to a jurisdictionally based inertia floor level, so one for Northern Ireland and one for Ireland, to deal with the potential system split event that we could have on the island system, because of there's essentially a single double circuit line connecting the north to the south, and a contingency of that will cause a split in our power system. So having regional inertia, we feel, is important, and we're going to develop a policy on that. One of the new policy areas that we're currently is under development is the concept of system strength. So as even Charlie mentioned earlier, we're transitioning to a system that was largely dominated by synchronous thermal generation to one that is dominated by inverter-based renewable sources, and the different characteristics of that generation has an impact on what we call our system strength. And the plan is to develop metrics and a policy around what are the needed characteristics of having a strong system in order to ensure that that increased penetration of inverter-based resources on the system remain stable. The rock-off limits that Dave has mentioned, we spent many years getting up to the 1 hertz per second rock-off standard that we have on the system today, and we see that continuing at least to the end of this decade, remaining at that 1 hertz limit. But beyond that, we have a plan to review what the system needs are, what the capabilities of users of the power system are, and whether that limit can evolve into the future. But for now, it's staying at 1 hertz per second. The SNSP metric then has been a really important metric for us over the past decade. And as we've mentioned, we're currently operating with up to 75% of our demand being able to be met by non-synchronous sources. While we're going to maintain this SNSP metric into the future, our plan is to move away from it as an actual operational limit. In anticipation that it'll ultimately be replaced or partly replaced by the system strength policy that we're going to develop. However, we still will maintain SNSP as a key metric, and our aim is to, from a metric point of view, to be able to get up to a 95% SNSP by 2030, and then as close as we can to 100% SNSP by 2035. So it's still going to be a very important metric for us, and a measure of how we're doing on our roadmap in terms of integration of renewables onto the system. Similar story really for the min number of units constraints. So David mentioned that we're currently able to operate the island power system with down to 7 large conventional units on, and we maintain that limit for dynamic stability purposes. But given our objectives to decarbonize, the plan is to reduce that min number of units constraint down to 3 or less by 2030, and then our overall aim is then not to have any requirement to run conventional generation units by 2035 when there's sufficient renewables available. Obviously, we may at times still need to run other sources of generation if there isn't sufficient renewables available, but when the renewables are available, we want to be able to maximize the output and not depend on I suppose fossil fuel generation to meet our system needs. So that's an overview of dynamic stability kind of key objectives, and in the roadmap itself, for each of the three policy areas that I mentioned of dynamic stability, reserves and ramping, and system security, we have this, I suppose, milestone plan or roadmap for each of the individual policy areas, how we expect it to evolve over the 10-year horizon of the plan, giving a bit more detail in the first 5 years and a higher level plan as we look further into the future out to 2035. So on this plan, kind of just to talk through some aspects of it, at the top we have some of the key changes impacting our system. So things that are driving some changes in our policies. And for example, we have here the connection of new HVDC interconnectors of GreenLink that's already connected. We have our Celtic HVDC interconnector connecting next year. That's going to increase our largest in-feed and out-feed on the system and will drive increased reserve requirements. We have offshore wind coming in the future and other system reinforcements into the future that will drive some changes in our operational policies. The reference to inertia sources there and LCIS. So LCIS stands for low carbon inertia services. That's one of the key enablers of the evolution of our dynamic stability is our plans to source inertia from alternative sources to conventional thermal generation that we rely on today. And in a couple of slides, I'll focus a bit more on that as a key enabler of this dynamic stability plan. And then for each of the individual policy areas like inertia, ROCOF, SNSP, MUON is min units on the system. We kind of set out the starting point for the policy area today and how we expect it to evolve over the decade, and the color coding here sets out our kind of a process of analysis, trialing updates to our policy, and then actually implementing policy. So there, and towards the end of the presentation, I'll give a bit of an overview of that sort of the governance and the process in place that we have for making these significant policy changes on our system. So that's kind of an overview of dynamic stability, and you know, for each of the other policy areas that I mentioned, reserves, ramping, system security, there's a similar roadmap like this. Now we won't go through that today, but it's all available in the roadmap itself. So that roadmap kind of sets out what our objectives are in terms of the evolution of those policies to try and reduce our dependency on conventional thermal generation on the system, to allow more renewables to meet demand. And there's some really important key enablers needed to be able to deliver on this plan, and the published document calls out these and a number more, but I think these are kind of maybe some of the three maybe key areas, and spanning different areas from the new services or ancillary services that we need to be able to operate the system, and those low carbon sources of inertia. From an operational point of view, in terms of our capability in the SONI and EirGrid control rooms to be able to operate the power system with these new challenges coming, we'll need new tools and capabilities in the control rooms, and also supporting the control rooms to be able to operate at these higher renewable levels. And then the third area is around improvement of performance standards for users of the grid. And I'll show an example of it, the development of fault ride-through capability for demand facilities that we're working on currently. So the first area there, this key enabler of new system services, or sometimes referred to as ancillary services in other jurisdictions, is our low carbon inertia service. And this is about getting new sources of inertia, reactive power, and short circuit contribution, the kind of services that are inherent in any synchronous generator that's connected to the system. We want to be able to get that from alternative sources. And we have already completed a procurement process whereby we have procured 11 GVA seconds of inertia services that's spread across 6 synchronous condensers that are spread across the system, or will be when they connect. And that this 11 GVA seconds, remember our minimum inertia floor on the system is 23 GVA seconds. So this is about 45% of our inertia floor requirements that we're hoping to procure, or we have procured through this service. And we're in the process of developing a second procurement process to procure additional low carbon inertia services. And again, all this is intended to reduce our dependency on running conventional thermal generation to provide inertia on the power system, as well as reactive power and short circuit contribution. So these new synchronous condensers are going to be connecting onto the system over the next number of years, and it will enable us then to reduce that conventional thermal generation requirement. So a second key enabler for our roadmap is in the area of enhanced operational tools and capabilities that we need on the system. So today, like we already have some fairly advanced capabilities in use in the control room. And
Simon, we lost your voice. It looks like you're still speaking, but we can't hear you.
so we've identified some key areas of focus in terms of development of new tools and capability, particularly around forecasting of demand and renewables on the system, in a system where our generation sources are going to be predominantly weather based. Obviously, the forecasting capability is really important. Secondary then is sort of high resolution observability and monitoring. So that today we have a fairly extensive phaser monitoring unit capability on the system, but we kind of recognize that we need to enhance some of the visibility of that in terms of real-time operation of the system, and kind of broaden the scope of it throughout the system to have more users, both generation and demand sources, monitored so that we can see some of the very maybe high frequency or low frequency type of events on the system. Control capabilities, we'll have a lot of additional onshore and offshore wind, lots of new solar connecting to the system. So as Dave mentioned at the beginning, we're a centrally dispatched system, so having control of those resources, both active power and reactive power capability, as well as other devices on the system, enhancing that capability is going to be important. And then the fourth area, and a very important one, is our modeling of the power system itself and enhancing that. So as I mentioned, we have some fairly advanced real-time RMS dynamic stability, transient stability monitoring that's used in the control rooms, both to look at real-time and look ahead system conditions. And it has been a really powerful tool in getting us to operation at 75% SNSP today. but with the increase in the level of inverter-based resources on the system and the interaction between those, we know we need to develop our electromagnetic transient or EMT simulation capability. So we already have in our grid codes, there are requirements for users of the power system to provide models, EMT models, but we need to enhance and develop our own internal capability to be able to use those models and perform the analysis that we need to ensure the system can be operated securely. And then just the third key enabler that I've focused on here is around the performance standards of users on the power system. And we have a particular issue in Ireland with a very high proportion of our demand being made up of data centers that have connected onto the system over the past 5 years or so. So currently our annual, about 20% of our annual demand on the system is coming from data centers. And there's a particular issue with the performance of data centers during transmission faults that might be remote from their sites. And what we have seen, and I know other TSOs globally have seen as well, is that when data centers detect faults on the system, that they reduce their demand, they switch to their own internal backup sources. But from a system power system point of view, it looks like their demand has reduced, and we have seen some significant events in our power system of large imbalances resulting from that demand reduction. So we're actively working on new standards that would go into our EirGrid and SONI grid codes that would apply fault ride-through standards to demand facilities on our grid, similar to those that would be in place for and have historically been in place for conventional generation, for wind, for batteries, for HVDC interconnectors that can all ride through these type of events, but currently not demand. So that's a gap we need to fix, and is a really important one in enabling the delivery of our roadmap. So that's the overview of the roadmap itself, and just a couple more slides just to provide a bit of background framework on sorry, the lights have come back on here, on the process by which we manage changes to operational policy and stakeholder engagement. So the policy changes that we've spoken to, and Dave showed a graph earlier of how, say, the SNSP metric has evolved over a number of years, and it has incremented in 5% increments, because we go through a very rigorous process of studying the impact of a policy change in our offline tools. We then if those studies show that we should be able to make the policy change, we then trial it in a live system trial, maybe for a couple of months. We evaluate the performance of the power system during the trial, and if everything goes as expected, at the end of that we approve the operational policy change. So some of those big policy changes can take maybe a year or more to make by going through this process, but we think it's really important that there's a very rigorous and appropriately governed process by which we make these policy changes. And we have experts in both SONI and EirGrid that sit on a policy review committee that is kind of provides this evaluation and authorization or approval to make these policy changes on the island. And my final slide then is a bit about the broader framework of what we've discussed today. So we've focused on the operational side of what's needed to meet our future policy targets in terms of renewables integration, and the operation side is one of 4 areas that EirGrid and SONI have set out in our overall plan, which is called Shaping Our Electricity Future. So as well as delivering the operational capabilities we need, it's also about delivering the network, the transmission lines that we need, about the development of the energy and system services markets to pay for the things, the services that we need and pay for the energy. And it's also about engagement with key stakeholders, with communities in terms of delivering the plan itself. So we have, the illustration here is of our Shaping Our Electricity Future Advisory Council, which has representation from across industry and key stakeholders, and that there is a dependency in terms of delivering this on those key stakeholders and industry in terms of delivering the services that we need, the tools that we need, and even the funding from a regulatory authority point of view, the funding that we need to be able to deliver on this plan. So that's kind of the end of the presentation. David, I don't know if you wanted to come in at the end there as well, or we can say that the plan is published on our websites. There's a link there, but you should be able to find it fairly easily if you search for that on either the SONI or EirGrid websites. So I'll pause there, and
I'm happy for Charlie to maybe cut into the question session. Thanks, Sam.
Okay, great. Nice job. Nice overview. You guys got your hands full. A big job for a little island.
Absolutely.
Yeah. So we've got a lot of questions here. Actually 24 questions. So our listeners have been listening intently and asking questions. So let's just dive into them. The first question is, can you provide insight on how EirGrid and SONI protects the system from problems like what Spain just faced, i.e. high renewable penetration, instability, blackout?
Have a go at that. I suppose, I mean, we're we're awaiting kind of more detail on understanding of what happened in Spain and Portugal. So we can't really say what the underlying cause. We don't know what the underlying cause of that is ourselves, and whether or not it's related to high renewables or not. I suppose from our point of view, in operating up to 75% SNSP on the system today, it's been a very careful process by which we've got to be confident that we can securely operate at that level. The decade or more than a decade worth of work that went into building up to that point, and the development of the tools and services that we needed on the system to be able to do that safely and securely. And one example, I suppose just one example of that is what I mentioned, the online stability assessment tool that we have in our control rooms called LSAT, Look Ahead Stability Security Assessment Tool, which is looking at real-time snapshot of the system and performing transient stability analysis for all the sort of credible contingencies on the system, and it's able to tell the operators in the control room, that we are within security limits, or if in the future. It also has a look ahead capability, so we're able to warn if there's a potential risk in the future. It gives time for the operator to take action to address that. So that's a really important tool that has provided a lot of confidence, in our real-time operation of the system, that we can do it safely and securely.
Yeah, I think that's probably fair, Simon. Just in the context of, We do have those operational tools. Again, sort of as a centrally dispatched model, it gives us that sort of ability to take the actions quite relatively, I suppose, with the tooling in terms of wind dispatch tool and how we can manage those sort of insecurities. The controllers will take those actions to make sure that the system is stabilized. The dynamic of our system, you know, I suppose, is an energy peninsula. You know, in the European system, you really have Spain, the Iberian Peninsula with Portugal. It is sort of a, you know, for us, it's very similar in terms of the dynamic of the system. Northern Ireland is loosely interconnected with Ireland. So Simon says our biggest issue is that sort of insecurity between sort of Northern Ireland and Ireland. And managing that sort of power flow is probably one of our biggest sort of risks against those single largest in feeds or out feeds and those events. But again, that operational policy review committee is really important in the overall process because it does give us the guidelines and the guardrails within which to sort of operate the system and make those, you know, significant policy changes happen so that we do it safely and securely. Probably, Simon, you mentioned the phaser measurement units earlier. Our reliance on those to then do post-event analysis and then calibrate the models and bring that back into LSAT and update sort of the responses and the characteristics of the devices on the system is really important as well. And in the worst case scenarios, well, you know, take units out of control actions to make sure that they don't contribute to future faults until we resolve that through analysis studies and then approvals in the OPRC review process as well. So we're alert. Charlie, is probably the main thing is sort of how we're working towards ensuring that we maximize the value but manage the security.
Yeah, it's a very, very meticulous process for sure.
Yeah.
Okay, let's move on to the next question. I'm going to expand the next question just a little bit. The question is, do any wind inverters utilize grid forming settings? I would expand that just a little bit to plans for grid forming controls on batteries. Any plans coming up?
Yeah, so today, no, we don't have grid forming applied on the system, but it is coming, and as part of our, we didn't really get into it in today, but as part of our policy roadmap, we have a plan to develop. We're developing a grid forming strategy or roadmap as well, and there's work underway on that at the minute. So that's looking at things like what are the standards that we need to go into our grid codes for grid forming. You know, what analysis do we need to do? What are the particular characteristics, I suppose, that we need on our power system? Because you know we're aware that standards are being developed by other TSOs and at a European level as well by SONI. But are there any sort of unique characteristics for our islands that might drive specific grid forming requirements for us? So a lot of work gone into kind of developing our strategy on this, and hopefully as well leading to a trial of it at some point in time. But yeah, it's coming and we're getting ready for it.
Yep. Okay. Next question is a little bit more, I think, in the direction of markets. Curious regarding the proposed low carbon inertia services. Do you envision a closer to operational market where DERs and assets could potentially key into?
In terms of, is that about it in terms of inertia or other services, do we think?
It's a proposed low carbon inertia services, right? It sounds
Yeah.
specifically about a closer to real time market for inertia services.
But potentially, yeah. The low carbon inertia services procurement that we have completed is a long-term. It's a fixed-term contract. It's a 6-year contract for essentially people to build new synchronous condensers and connect them to the system. We are in general, our system services arrangements are going through or will be going through a change over the next year or two, and we are transitioning to more day-ahead procurement of services, initially starting with reserve-only services, but we anticipate that will evolve in future iterations, and certainly there's I suppose a desire coming from I suppose our regulator and from Europe that any services are procured competitively and closer to real time.
I think there's maybe just, Simon, then the part around distributed energy resources and sort of how that plays into the low carbon inertia services. In the question, if I'm correct, Charlie, if that right. And I suppose at the end of the day, I suppose, as Simon has mentioned, our initial drive there is to, ensure that we have equivalent, low carbon inertia requirements coming through to replace our conventional units, to move us from the 7 must-run units down to 0 by 2035. And I suppose then there'll be opportunities, after, due process and consideration, how distributed energy resources could play into that market in the longer term. So it's not something that we have at the moment, but it's certainly something that we're aware of, that the market and regulators are interested in exploring. So don't know if you have any thoughts, Simon.
Well, there's a lot going on in that area, and hopefully by the time
Yep.
you get around to that point, you'll have some other experiences that you can draw on from some of your fellow system operators.
Absolutely.
Let's move on to the next question. The next question we could spend the next hour discussing, but maybe just a quick response. Did the higher share of IBRs impact the effectiveness of EirGrid's existing protection schemes due to the lower short circuit current contributions?
It's probably the system strength policy world that we're really getting into there. So Simon mentioned earlier that system strength policy, defining the metrics and how that ties together in that IBR world will be sort of the #1 key priority to understand how it impacts our protection schemes. So that's a piece of work that we have kicked off, and it is in the plan, Charlie.
Yeah. Okay. Next one on synthetic inertia. And I interpret synthetic inertia to mean fast frequency response, but the question is, will you allow synthetic inertia to contribute to your minimum synchronous area inertia requirement?
Yeah, so currently it doesn't, and Charlie, we have the same interpretation, I think, of synchronous inertia, and we have a product, we have a frequency response product called fast frequency response, which is a minimum of response in 2 seconds, but can be as quick as 150 milliseconds, response within 150 milliseconds. So that very fast frequency response is a service that some inverter-based resources provide to us, but we don't class that as sort of, it doesn't count towards our inertia requirement currently. So our LCIS procurement process has focused on synchronous condensers, synchronous sources of inertia initially, and we are, I suppose, going to be evaluating the potential for, let's say, grid forming sources of inertia in the future. But there's a good bit of work that we still need to do, I'd say, on developing our grid forming strategy and trialing that on our system before we get to that point.
Yeah, something to keep your eye on for sure. I'm going to try to get 2 more questions here in the last minute or two. The first one is about the ramping rate on the interconnectors. Isn't 5 megawatts a minute ramping rate a little low for providing security?
Yeah, so that's correct. That the existing 3 HVDC interconnectors that we have a nominal ramp rate of 5 megawatts per minute. So it's 15 megawatts if they were all ramping at the same time. And I suppose that is something, again, as part of the roadmap where we're keeping under review. I suppose for given the size of our system and the variability of say wind on the system, that we've been cautious, let's say, about the speed of interconnector ramping, just given the size of our system. But we know there's benefits in terms of being able to increase that, but it does bring maybe challenges as well if the I suppose if the interconnector ramps are not aligned, let's say, with the ramp and wind up or down, that could bring challenges. But it's something we're actively working on at the minute, and we've a fourth interconnector coming, the Celtic interconnector, next year, and we're doing quite a bit of work, doing studies now to determine what the future ramp rates on the interconnectors will look like.
Yeah, another thing to keep your eye on.
Yeah, maybe just there's other sort of products and response curves that the interconnectors do have. So, there's a scheme in Northern Ireland with our HVDC interconnector that allows us to manage security events in the event of a north-south trip. So there are sort of, frequency response curves that are effective, at much sort of greater rates, if I'm correct, Simon.
Yeah.
So, it's not just, that's really just for the market trading.
Okay, we're a little over time, but I want to get in one more question from Simonelli. It's a very practical question. It says your minimum load levels look challenging. How are you handling the high voltage issues and excess generation conditions at those minimum load levels?
Well, I suppose in pure sort of balancing supply and demand, because we've been able to reduce the min number of units on the system down to 7. So the minimum, and we have sort of incentivized a reduction in the min gen of those min units. So we have, I suppose, what relatively large units that are able to operate at quite low levels, because of that. So that the incentive there was more to make more room for renewables on the system when there's high renewable periods. So I suppose we don't really have a min gen kind of issue today. There is, yes, the voltage issue is in some particular parts of the network, particularly in Dublin, in the city, where there's a lot of cable transmission network. When we have challenges with high voltages at times, and we're having to keep conventional generation on to help absorb reactive power to manage those high voltage issues. We also have a lot of capability in wind itself in terms of its ability to absorb reactive power at times as well. Yeah.
And probably in the north. In the north, I suppose there's proactive control engineer strategies just to manage those sort of overnight low load levels. So in Northern Ireland, our minimum load sort of hits about 400. Our minimum generation level, when you've got the 3 units on, is 400. So we do have those voltage rise issues. We do have limited sort of reactor capability on the transmission network as well. So the control engineers are having to be proactive, set the voltages to allow the voltage to rise and still remain within sort of operational security standards. So it's definitely an issue. But again, I suppose with the rollout of additional IBRs, potentially it gives us more flexibility in terms of VAR absorption in the future. But definitely something that we're concerned with.
Well, it sounds like you'll keep a few new tools in your toolbox.
Yep.
Or you'll get a few more new tools in your toolbox.
That's what we need.
Yep. Okay, so we're a little bit over, so I kind of need to wrap it up. I want to thank Simon and Dave for this really informative webinar. on the organizational plans for high IBR systems over the next 10 years. I think it's going to serve as a really great source of inspiration for everyone working in this field. You're really at the cutting edge of things. As I mentioned earlier, an email will go out once the video file has been posted, and we'll answer the questions we didn't get to and get them posted as soon as possible. We appreciate your participation, and if you'd like to stay engaged, I'd like to invite you to participate in the next ESIG webinar on May 12th on speeding up interconnection studies, another critical issue facing the industry. I'd also like to invite you to have a look at the agenda for the ESIG Forecasting and Markets Workshop in Nashville, Tennessee during the week of June 23rd. Plenty of time to register and another outstanding lineup of topics and speakers. Further information on all of our webinars and events can be found on our website at esig.energy under events, and you're all invited to attend. Information on all the G-PST webinars can also be found at globalpst.org. Simon, Dave, I want to thank you again for this very timely webinar and thank all of you for your interest. We look forward to seeing you again in the near future. And in the meantime, everyone, take care, stay safe, and thanks again for your participation. See you soon. Thanks, guys.
Thanks, Charlie.
Thank you so
Thanks,
much,
everyone.
Charlie. All the
Bye.
best. Thank you, everyone. Bye-bye.
Bye.